In this video, we are going to look at nonlinear buckling analysis using line models. And we are going to look at this question: the roof beams of a warehouse supported by pipe columns. And we know all the dimensions for the column, and the material is steel with modulus 210 gigapascals. And the bottom of the column is fixed, and the top of the column is subjected to 4 different conditions. And we are going to look at part 1. The upper end is pinned, and the beam prevents horizontal displacement. So this means the column has pinned on the top and fixed on the bottom. So pinned, fixed end condition. And the critical buckling load from analytical solution is 447 kilonewtons. Now we go to Ansys workbench. In Ansys workbench, for nonlinear buckling analysis, we just need to create static structural analysis. And for the material, we need to create a steel with Young's modulus 210 gigapascals and the Poisson's ratio 0.3. And we can delete the structural steel. And for geometry, we are going to import a geometry created before for this question and update the model. Now double-click to open Ansys Mechanical. First, set the material to be steel, and then do the mesh. And we are going to divide this beam or column into 50 equal elements. So insert the sizing for this line. the number of divisions to be 50. Generate a mesh. And now, in order to for buckling to occur, we need to apply a small force in the middle of the column. For convenience, we're going to create a named selection. So a named selection using worksheet, add, so define the node with y coordinate to be 2000 millimeters. So we pick the node in the middle of the column. Now go to static structural and insert displacement. So first the displacement on the top, because it's pinned, and we constrain X and Z movement with Y movement to be free. So that point can go down. And on the bottom is a fixed support. And we apply a force on the top. So a compressive force. And 500 kilonewtons. In order for buckling to occur, we need to apply a small force in the middle. So use named selection and component, apply in X direction 5 newtons. And go to analysis setting. For nonlinear buckling analysis, we need to change large deflection to on to do nonlinear analysis. Then go to auto time stepping, change to on, and increase the maximum sub-steps to 2000, and initial step 200, and the minimum 200. And for solution, insert deformation, directional X. And we can also get deformation Y. And then we can solve the model. After solution, we go to directional deformation. And what we can see is, you see this plot. And around here, we see that valley and the peak. So that is where buckling actually occurred. So click on, we can go to the table and look at the maximum to be this much, 26 millimeters, and retrieve this result. And because we applied 500 kilonewtons, and 500 kilonewtons is ramped up to 1 second, so to here, and given the current time 0.895, so we use 500 multiplied by 0.895, so we get 447.5 kilonewtons. And the analytical solution is 447 kilonewtons, so very close to the analytical solution. And we can also go to result, change to auto, and so play the animation. We can see the buckling occurred. And that is how we do nonlinear analysis, nonlinear buckling analysis in Ansys. Thank you.